Okay, yeah, so we can start now. Yeah, so I can say hypothesis, just a statement which define, okay? It may be defined as a statement about one or more population. So this is a statement that describe why something happens. It's a statement that motivates the researchers to do a research. So for instance, when I was doing my bachelor's degree research at CBU, it was that time of cholera. Okay, it was that time of cholera, and then um, the Ministry of Health advised people that you don't buy food from street. Okay, that was the advice from the Ministry of Health. Okay, then now when you look at that advice alone, it seems that it's difficult to implement. It cannot work. Okay, that advice alone to stop people buying food from from the street, it can't work. Why? Because you find that there are people who do not have okay, who um, the people who buy food from the street is because that is what they can afford, and there are so many people who can only afford to buy food from the street. For instance, when you go to some of big bakeries, or maybe if where you work you start baking scones there, you find that you're going to sell one scone at 10 kwacha, then a scone in the street is 2 kwacha. Do you think a poor person can manage to go and buy scones from Nando's instead of buying it from the street?
No.
The answer is no. So you find there are so many people who are buying food from the street because that's what they can afford. And also the street is a source of income for men Zambian. There are so many poor women out there who goes on the street to survive, to sell whatever they sell on the street. It's not like they want to be there. They just have to be there for them to survive. So just to say, okay, stop buying food from the street so that you don't get sick. Where are they going to buy food from? These people. So I assume that if we educate these people, people are selling food on the street, to educate them about hygiene, how can they prepare their food in a hygienic manner so that they food can be fit for consumption. Okay, they can prevent diseases. So I was assuming that at that time, if we improve knowledge, we can improve what? We can improve hygiene. So I wanted to uh, find out. My assumption was that those people who sell food at the street have raw knowledge about food hygiene. Okay, but is this true for me to say people who sell food on the street have raw knowledge about food hygiene? So this is not true. So now I just wanted to go on the street and find out if indeed these people have raw knowledge. So this is a hypothesis that I had. You say, okay, these people who sell food on the street have raw knowledge, and I wanted to find out if indeed they have no knowledge. And when I went there, I found out that yeah, for some people they have raw knowledge, but again I realized that a lot of things needed to be improved for my study. Yeah, but you'll talk about those things later. So a hypothesis motivates you. You find a problem and you come up with your own answers. Then now you want to find out, is this true that I'm thinking about this problem? So you go on the street and you do your study. So hypothesis or statistical hypothesis are hypotheses that are stated in such a way that they can be evaluated by appropriate statistical method. So we have what we call statistical hypothesis. These include hypotheses that can be stated in a way that they can be evaluated by statistical methods. So when I talk about statistical method, we're talking about a method of collecting the data, you organize the data, you analyze, you interpret it. Okay, and now as you're analyzing that data, you can analyze using mathematical or statistical methods. Okay, so a hypothesis in research or in biostatistics, it will be stated in a way that it will allow us to evaluate it using appropriate statistical techniques. So that is what is important. So hypothesis testing. What is the aim of doing this hypothesis testing? Is to use information gained from a sample to make inferential about a population. So like I was doing my study, I was assuming that women have raw knowledge. So I went to Masara, that's where I was doing my study, and collected information about food safety knowledge and awareness among women. So when I collected that information, I got the information from a small sample. Okay, from a small sample. After getting this information from a small sample, I found out that there was raw knowledge of food safety and awareness in Masara. So I concluded that just from this knowledge, from this small sample, I concluded that main people or in the people in Masara, including those that did not participate in the study, the majority had the raw knowledge about food safety and hygiene. Okay, so we used this hypothesis testing to gain or to make inferential. So inference is a conclusion. So we can use a small sample to make a big conclusion about what? About the population. So that is why we do this. So the two basic approach to statistical analysis include estimation with confidence interval and the p-value. So now the way we test this interval is to use estimation, which where we use a confidence interval. So learn what confidence interval is, and we can use the p-value to test the hypothesis. Also learn what a p-value is. So these are the two basic approach to statistical analysis. Okay, so now hypothesis, we have two types of hypothesis. We have two types of hypothesis. We have a null hypothesis and a what? And alternative hypothesis. Yeah, so you have a null hypothesis and alternative hypothesis. So these statistical analysis are not only concerned with summarizing data, but also investigating relationships. So then what is the difference between the null hypothesis and the, the alternative hypothesis? So when you look at statistical analysis, unlike descriptive analysis, you are not just concerned about summarizing the data that you find. You are concerned about investigating what? Relationship. Okay, so we are given an example here. An investigator conducting a study usually has a theory in mind, e.g., cigarette smoking is associated with lung cancer. So when you want to do a study, like you are saying, you already have answers in your mind. Okay, or you can use theories. Some of these examples include when you want to do a research about, maybe you have seen that there is rise in cases of lung cancer in your area. So you can attribute it to smoking. You can say, okay, cigarette smoking maybe is a cause of this lung cancer in this area. So when you go to do a study, you want to find out if indeed lung cancer is associated with what? With cigarette smoking. Okay, you can have an hypothesis to say bathing daily shortens one lifespan. Is that true?
Oh,
Yeah, so birthing day shortens one side. Okay, so now I was thinking there's when you look at uh, when you look at maybe accidents, okay, you find that many people who are involved in accident are actually men. Many people who die in road accident are men. So what is the reason behind? What do you think is the reason behind?
I feel maybe what is mean are Christians because
Sorry?
men usually they are risk takers.
Men
Mostly
there
you find
usually.
them,
Mm-hmm.
the risk takers. Mostly you find them driving maybe with excessive speed. I feel they have less fear compared to women.
Yes. Yeah, yeah. So even when you look at vehicles that are involved, are those that are driven by men? Mostly, those are the vehicles that are involved in road accidents. So now, that answer that we have given is just a theory in our mind. Okay? So we need to do a study to find out if that is true. Or maybe it's because there are few women who drives on the road than male. So look at maybe we will stand somewhere maybe between Dore and Kapiri and start counting cars that are driven by male and those that are driven by female. Find that maybe 90% are driven by male. Okay? And when you look at long distances, maybe find that most of the cars are driven by male. So now, I'm just trying to say, we have all these answers. You have your own answers in your mind. Say, okay, men are risk takers. Usually they drive at a very high speed. Okay? And someone is thinking maybe it's because there are more cars that are driven by men. Okay? That's why you find that this side there are so many accidents involving men because the cars are driven by men. But we now want to know why. So we go on the ground and do a study to find out, to prove these answers that we have, and we can do them using statistical method by counting how many cars are driven by men, how many are involved in accidents, those driven by men, what is the percent, and those that are driven by female, what is the percent. So we can do those investigation to find out. Okay, so that is the hypothesis now. So the now the conveyance of the start hypothesis is a null hypothesis. Okay, so a hypothesis tries to find out if there is a relationship between variables. Okay, it will say there is a relationship. So I have two types of hypothesis. A null hypothesis will always be say there is no relationship. Okay, a null hypothesis will say there is no relationship. So like you say, men drive. You can say driving at high speed is associated with road traffic accident. Then the null hypothesis say driving at high speed is not associated with a road accident. So we have two types of hypothesis. The null hypothesis says there is no association. So in any case that you are studying, the null hypothesis establishes that there is no association or there is no difference. If you are given two instances that you are comparing to see a road traffic accident, maybe difference between male and female, the null hypothesis is going to say there is no difference. Okay, then the alternative hypothesis is going to say there is different. So these are two types of hypotheses that we have. Okay, so from the example that we are given, the null hypothesis, for instance, can say cigarette smoking is not associated with lung cancer. Okay, or bathing daily does not shorten one's lifespan. So these are now hypotheses. Then the alternative hypothesis on top here will say cigarette smoking is associated with lung cancer, or bathing daily shortens one's lifespan. So that is an alternative hypothesis. Okay. Then when we look at statistical inference, so hypothesis testing is a method of deciding whether the data are consistent with the null hypothesis. Okay, so when you go to hypothesis testing, when we're talking about hypothesis testing, we want to know whether the data is consistent with the null hypothesis. That means we want to know if the data that you have, the data that you correct, support the null hypothesis, which says there is no difference, there is no association, or it refuses the causal effect. Okay, so you correct the data and want to see if it is consistent with the null hypothesis. So you do that. When you are correcting the data, at the end of the day, you need to calculate what we call the p-value. So the p-value calculation is the important part of this procedure. So you need to calculate the p-value. So given a study with a single outcome measure and a statistical test, hypothesis testing can be summarized in 4 steps. So now look at the 4 steps of testing the hypothesis. The 4th step of testing the hypothesis. What are these steps? Number 1 step is to state your null hypothesis and your alternative hypothesis. So you state your null hypothesis, okay, and alternative hypothesis. After that, you choose a level of significance. I know that maybe this can be sound as Greek, but you don't have to worry because we'll look at them one by one. So you state the hypothesis, then you choose the level of significance. The level of significance is a point at which you are going to say, okay, at this point I will not accept this, or at this point I will accept this. It's more like you are selling things and you want someone come to negotiate. You say, okay, I'm selling this at 500 and 450 is the last price, below which I cannot accept this. Okay, I cannot accept the price. Or you want to give someone something and you say, for you to get this, you have to do this and that. We have to reach this level. Or if you don't reach this level, I will not accept. Okay, so this same applies to health. If you are trying to compare two things, there's a level at which you can agree that, okay, this can cause this or this cannot cause this. So that is the level of significance. So after you have chosen the level at which you are going to accept or do not accept certain result, you go now and conduct the study, observe the outcome and compute the probability of observing your results. So you, after you do that, you conduct your study and you look for the probability of observing your result, or result more extremely. If the null hypothesis is true, so you look at the p-value, you calculate the p-value and you find out if the null hypothesis is true. So we are going to, these are some of the most important things, the significance level and the p-value in testing our hypothesis. So what is a p-value? A p-value is a probability, okay, of obtaining a sample statistical mean or proportion as large as or greater than the one actually observed. Okay, a p-value, I'll repeat this one, is a probability of obtaining a sample statistic mean or proportion as large as or greater than the one actually observed. What does this mean? What do you think is the meaning of this statement? Hello?
Hello.
What do you think is the meaning of this statement?
Let me try to think.
They say a p-value is the probability of obtaining a sample statistic which can include mean or proportion as large or as greater than the one actually observed. What does this mean?
I think oh, let me try to gather.
Okay, so let's look at the airplane when it is up there. What is the size of the airplane that you observe?
Different sizes.
When it's up, is it as large as it is, or
No,
it's very small, right?
no,
It's very small, like even like a pressing iron when it is above there. It's very small.
yes.
Now, what is the probability that you can see as big as it is? So now, a p-value is more like an instrument, though it's a number. Now, it's more like an instrument which we can use to magnify the size of an airplane in the sky to see how big it is. Even when we're standing on the ground, we want to see how big that airplane is. So we can use a certain, maybe a microscope, okay, or some lenses that can zoom to see how big that that airplane is. Okay, we want to zoom to see how big is that airplane. So that is a p-value. So it's more like a microscope. It measures what you cannot see with your naked what? With your naked eyes. It shows you the difference. If you are looking at the difference, it shows you the difference that you cannot see with your what? With your eyes. Okay? Do you have a friend?
Yes.
How strong is your relationship with your friend? So that question
Okay.
you can answer it, but
Mm-hmm.
you can answer it's a personal question. But have you ever heard people that say, "I thought she was my friend," after they are betrayed? Maybe they will say, "Oh no, I thought she was my friend. I even used to tell her about everything and anything." So all those that kind of relationship. So you cannot you can think you are very close to someone when you are not even what? When you're not even close, you can think you this person is your best friend when they are not even your best friend. Now imagine if there was a mirror or a microscope or a lens that we can use to view the relationship that you have with people, to see what people are thinking about you. What can you do? There's going to be we we are going to be avoiding people when you just to check how your relationship is with someone. So now the p-value is that range now we use in research when we see that maybe people are having malaria, and you want to think that maybe not sleeping under mosquito net is the cause of malaria. So now you get this p-value to examine that relationship. Okay, because now what we can see that people are not sleeping under mosquito net and are having malaria. But we don't know how strong that connection is between not sleeping under mosquito net and having what? And having malaria. So you will get these two, which is a p-value now, to examine that relationship, to see how strong it is, to see how connected it is. So a p-value, on the other hand, is a measure of how much evidence we have against the null hypothesis. Okay? So remember, our null hypothesis says if you are looking at malaria and sleeping under mosquito net, the null hypothesis will say there is no what? There is no connection here, there is no association, there is no relationship. Okay? No association. That is the p-value. The p-value is going to no. The null hypothesis say there is no relationship whatsoever between malaria and sleeping under mosquito net. So now a p-value, it will measure how much evidence we have against the now what? The null hypothesis. It will show us the evidence, how much evidence we have, so that we can say there is a relationship. There is an association between sleeping under mosquito net and having malaria. So this p-value, it will help us to bring out this relationship, to show us the strength of this relationship. Either indeed there is a relationship or there is no relationship at all. So that is a p-value for us. So we use a p-value to make a decision about whether to reject or not to reject your now hypothesis. So since the hypothesis says there is no association, we need to do a research. After you have done a research, what are you going to do? Is either you reject this hypothesis or you fail to do what? To reject it. So a p-value is a value that you are going to use to make this decision whether to reject or fail to reject your hypothesis. Okay? So if the p-value is less than or equal to alpha, conclude that the data does not agree with the null hypothesis and you reject the null hypothesis. So if the p-value that you find after you have calculated, after you've done your research and you calculate the p-value, if the p-value that you find is equal or less than to the alpha, okay, which is the level of confidence or the confidence level, okay, you reject the null hypothesis. You reject the null hypothesis which says there is no relationship between two variables. Then if the p-value is greater than or do not is greater than alpha, then do not reject the null hypothesis. Are we together?
Yes, sir.
Yeah, so we have already looked at these steps uh, for, for hypothesis testing, where we state the null hypothesis and alternative hypothesis. So often, statistical analysis involve comparison between treatment. Okay, so here we find that in health, these statistical analysis, they often involves comparison between treatment. Okay, between different treatments. Okay, so what are the ways of preventing malaria? Different ways of preventing malaria, apart from sleeping under mosquito net.
Maybe clearing the surroundings in case of any grass,
Yeah, so clearing the surrounding.
stagnant water, buy stagnant water.
Yes. Yes, so we have these different um, treatments, interventions. So you can sleep under mosquito net, or you can clear the stagnant water outside, or you can buy mosquito repellents. So now you may want to know which of these is more effective, or is there a difference between these? Okay, is there a difference between these? So if you want to find out if there is a difference between these, the null hypothesis is going to say there is no what? There is no difference. Then the alternative hypothesis is going to say there is a difference. Okay?
Yes.
So when you start comparing, or before you compare, the null hypothesis assume that the treatment effects are equal until proven different. So until you do a study, you cannot tell either the treatment, the interventions are different. So you as a public health professional, you'll be mostly required to develop what? Interventions to protect people or to prevent diseases. So before you do, you can come up with different interventions. Now, you want to select the most appropriate or the most effective intervention to treat people. So how do you do that? For you to select the most appropriate or the most effective, you need to do a study. So before you do a study, you prove that these interventions are just the same. So this, like in the court of law, when you go to court, if someone is still viva, how do you call the person who have stolen something in court?
In fact, not sure.
Sorry?
I'm not sure in fact. But
So do you say this one is a thief or is an accused person?
an accused, yeah,
Why do you say it's an accused?
because uh, that's seven.
Yeah, because you don't yet have evidence.
Evidence.
Or even when you have
Accused.
evidence, you have not yet,
Accused comes in when there is no evidence.
yeah, the court has not yet proven. Even when you have evidence, the court has not yet proven this person to be what? To be guilty.
Seven
Okay?
on this. Okay.
Yeah, so the person, even if someone has murdered someone, have done any crime, they are called the accused person until the court of law prove them to be what? To be guilty. So everyone is innocent until they are proven guilty. So this is just an example that we give, that before you do a study, the relationship that you expect, we say there is no relationship. Okay? Or if you are looking at different treatments, you say there is, all these treatments are equal until you prove the difference, until you do a study to prove the what, the difference, if the difference does exist. So as a public health intervention, as a public health personnel, when an outbreak comes, you need to come up with the interventions. You need to come up with programs to prevent that outbreak. And now, based on the resources that you have, you want to know which one the most effective. Okay, that such that if we use these resources, we can be able to do what, to prevent the diseases. So now, before you do a study to find out which one is more effective, we assume they are all the same. Okay, yeah. So that is the issue. So I'm just still emphasizing on the hypothesis. So when you're testing hypothesis, the null hypothesis states that there is no difference between different, there is no difference between treatment effects. So if you're looking at treatment, it's not just treatment, you can do a lot of things. You assume that there is no difference. Then the alternative hypothesis is assume that there is a difference. Okay? Okay. We have talked about the significance level and so on, and how to reject. So I think we have talked about this one, calculating the statistical test. We'll do them this one. So the statistical test is sometimes, instead of calculating the p-value, you can uh, do calculate the statistical test. Okay, so this statistical test, it can be calculated using um, the data that you have collected. So you have this general formula. This is a general formula for calculating the test statistics, which is an alternative of the p-value. So this one, it uses observed value minus hypothesized value over the standard error of the observed value. So we'll talk about this one later. We'll not focus on them now. So the statistical test is compared to distribution, what we expect if the null hypothesis is true. Okay, so this one we can use it as well to make a decision, just like we can use the p-value. Okay, so yeah, so the p-value, usually we set, for the p-value, we said is a point at which you can make a what, it is a decision. So you can use this p-value to make a decision about whether to reject or to fail to reject your hypothesis. So normally we set the p-value at 5% or 0.05. So if this is now alpha, okay, alpha is set at 5% or 0.05. So if the result, if the p-value that you find is less than or equal to 0.05, the result are statistically significant. That means there is sufficient evidence to reject the null hypothesis and settle for alternative hypothesis. Okay, so I'll repeat this one again. You collect data. You say, maybe you say, uh, we are looking at prevention for malaria. We say mosquito net and what? Mosquito net and the repellents. Okay, What is the effectiveness? Which one is effective between mosquito net and repellents?
Both.
Both are effective.
Yes.
Now, which one is more effective?
Okay, just say mosquito net.
Sorry?
Just say mosquito net.
Mosquito net. Yeah, so as yeah, when you do more or when you wake from the what is this malaria elimination center, you will understand that the effectiveness of these two interventions depends on many factors. One of these factors include the type and the behavior of the mosquitoes. Okay, the type and behavior of the mosquitoes. You can use a mosquito net, but let me connect this thing. Yeah, you can use a mosquito net, but we have some mosquitoes which bite or they bite, the peak biting hour, the time that they bite is 19 hours when people are not yet sleeping. Okay, so you find that by the time you go to the bed, the mosquito have already what? Bitten you. Can the mosquito net work for those mosquitoes?
Mm-hmm.
Yeah, they won't work. So they, we have different biting time and mosquito have different behavior. So it depends on the mosquito type and their behavior which you are dealing with. But you find that that's why they have introduced mosquito repellents. So now I'm not saying that mosquito repellents are more effective than mosquito nets. So what we need to do is to do a study to find out if they are more effective or not. So now when we want to do this study, we have mosquito repellents and mosquito nets. What will be our now hypothesis? So the now hypothesis is going to say there is no what? There is no difference, right?
Yes.
Then the alternative hypothesis,
It will agree to say there are mosquitoes.
there are difference. There is a
I mean,
difference.
there's a difference.
Yeah, there is a difference in terms of effectiveness. So now, to know if there is no difference or there is a difference, we are going to use a p-value. So when this p-value that we calculate is less than 0.05, which is the alpha that we set, it's less than 0.05, we know that results are statistically significant and there is sufficient evidence to reject the null hypothesis, which says there is no difference. So we're going to reject that hypothesis and settle for what? For alternative hypothesis, which says there is a difference. But if the p-value is greater than 0.05, there is not the result are not statistically different. So there is insufficient evidence to reject the null hypothesis. Therefore, we are going to fail to reject the null hypothesis because there is not enough evidence to reject it. So we will reject, we will fail to reject the null hypothesis. We are not going to say the null hypothesis is true. Okay? Why can't we say the null hypothesis is true? So this is just the language that we are using. Or in court, when you go to court, which one do they use not guilty or innocent?
Not guilty.
Why they don't use innocent?
I don't think you're completely innocent.
It's just because there is no enough what evidence at that time to prove that you are guilty, right? You have stolen some goats. When you go to court, they judge you. They find that you seem like there is no evidence that you have stolen goats. They will not say this person is innocent. They will just say this person is what is not guilty. Okay, because at that moment there is no sufficient evidence. Yeah, if we go to another court and evidence is produced, or later on evidence resurface, evidence appears from nowhere, you'll be arrested. But if they said you are innocent, they cannot arrest you, because where is now the evidence coming when you are innocent? So innocent simply means you have not done that thing. It's whereby actually it's you who knows. At that point when they release, they say you are not guilty. It's you who knows either you are innocent or not, because they can release you when you deep down in your heart you know that you are the culprit. So even in research, we don't say the hypothesis true. Okay, we just say we fail to reject the hypothesis. Okay, because there are no enough evidence to reject it, so we just fail. If someone else comes in and do the same study and find evidence against this hypothesis, can reject it, right? Yeah, so you have to look at the p-value. When the p-value is less than 0.05, you reject the null hypothesis. If it is greater than 0.05, you fail to reject the null hypothesis. Okay, so now as you are doing this research, you can make some errors. Okay, you can make some errors. The same example of the court. A court, someone can go to court. I have stolen goats. I know that I have stolen goats, but when I go to court, the court have find no evidence. They say no, this person is not guilty, but I know that I have done it. Do you think the court have made the right decision?
Yeah, because there's no evidence. You said.
Yeah, now that is an error, because there should be evidence that I've stolen goats, because I've really stolen the goats and I just refused, and the court let me go because they have no evidence. But in light sense, that is not a correct what decision. So in research, what I'm trying to say, you can make what errors as you are testing this hypothesis. You can make errors, and you have two types of error. There is type 1 error and type 2 error. So type 1 error simply means rejecting the null hypothesis that is actually true. You reject the null hypothesis when we say there is no difference between treatment. Okay, and in the actual sense there is no difference, but you reject this hypothesis, which is true. You have made what? An error. Okay, okay, let me repeat that one again. We say between mosquito repellents and mosquito nets, which one is more effective? So if in terms of effectiveness these do not differ, okay, then me I do a study and I find that they differ when actually they don't. I have made what? An error. This type of error is called the type 1 error. So it's the error where you reject the null hypothesis, which is actually true. Okay, you have made an error. Then type 2 error, you fail to reject the null hypothesis. That is actually false. So the null hypothesis is false, and you fail to reject it. You have made type 2 error. Okay?
Yes.
So here I usually give example of simple mathematics. I don't know if it will make sense. We can do this. I say 1 plus 1 1 plus 1 is equal to what? 2. 1 plus 1 is equal to 2. Then you are my teacher and you mark me wrong. Who is right between you and me?
It's you.
Yeah, so you will have made error when you are marking, because you have rejected the answer, which is what? Which is true, right?
Yes.
2 plus 1 is 2. So that is true. So you mark me wrong. So you have made an error in marking. You have rejected the answer, or you have marked the answer wrong when this answer is true. So this type of error, or the probability, the chances of making this error, is called the significance level, or alpha. Then we have type 2 error. A student write 1 plus 1 is equal to 3, and the teacher marks this one as a correct answer. Okay, who has made an error here?
But
So 1 plus 1 is what? Is equal to 3. The teacher has what? Has failed to reject this answer, and marked it what? Correct. So he has made an error to fail to reject this answer, which is what? Which is false. This is false. It's not 1 plus 1 is not 3. It's false. But the teacher has failed to reject this answer. So same can happen in research. When something is wrong and you fail to reject it, you fail to notice it, and you go ahead and accept it as the right thing, you have made an error, which is called type 2 error. Okay, any question on these types of errors? Okay, great. So this is just the same. Then we look at the probability, the statistical power. The statistical power is the probability of correctly rejecting a null hypothesis. So, your ability as a teacher, if we say 1 plus 1 is equal to 1 plus 1 is equal to 3. Okay? Then you correctly reject this answer. Now, that probability, or the chances of you rejecting this answer, is what we call statistical power. Okay? So this is your ability to make a right what? A right decision. Your ability to detect a difference in treatment when a difference actually does what? Exist. Are you able to identify the difference when the difference is there, or you fail? So your ability of doing that is what we call um, proper statistical power. Statistical power. So this concept of type 1 and type 2 error are parallel to the concept of sensitivity and specificity. Okay? Sensitivity and specificity. What is the difference between sensitivity and specificity? What is the difference?
I feel the other one is more specific.
It's not what?
The other one is more specific, and the other one
Very confused, eh? So sensitivity is the ability to detect the true positives. Specificity is the ability to identify the what? The true negatives, if I have not mistaken them. So when you go to the clinic, you are sick, you go to the clinic, you have malaria. They test malaria. They test you malaria and you find that you are positive. No, you are negative, but you have malaria. What do you call that diagnosis? So when you go to test, when you go to the clinic to test for the disease, the result can be classified into 4 classes. There is a true positive, okay? There is also a false what? A false positive. Then there is a true negative, true negative. It should be TN, and the false negative. Okay. So I said you go to the clinic, right? You have malaria. The truth is that you have malaria. You have it, and you go to the clinic. They do a test, and they find that you don't have malaria. Which of these tests are you falling under? Eh?
I mean, true negative.
You have malaria. You have the fact that you have malaria. Then you test negative. Which of these are you falling under?
It's false negative.
Yeah, you're falling under false negative because you have malaria, but the machine has told us that you don't have. So that is a false negative. So actually, each test that you have, it has a percentage where it can detect false negative or true or false positives. Someone is not sick. Someone is not sick. You are not sick. But the machine, whatever they are using to test, said that you are what? You are sick. That is a false what? False positive.
Positive.
And what is the cost of this?
You may end up prescribing wrong medicine or wrong medication when the rest of it.
Yeah, you give medication, you wastage of medicines. You are treating disease which is not there. And sometimes it's also become difficult to disable, okay, or to tell people later on that you are not sick. Imagine someone you tell them that you have HIV when they don't have. What is the emotion? What is the psychological effect of that?
Yeah, it happened at the facility where I was working. So
You see? So you can